Welcome back, everybody. Today we're going to start up Chapter 6, which deals with Java arrays. Now, the first few chapters of this semester deal with some of the basic data structures available to us in Java, with arrays being one of them. Now, an array is essentially just a list, and there's a lot of different ways we can do a list in Java, but the array is the most kind of simple and straightforward way we can make a list. All right, in 6.1, we're going to give you an overview of kind of what arrays are and how they work, and then we'll spend a few other additional sections going deeper, going further, looking at kind of the details of Java arrays. So here we go. So before we start talking about arrays, let's first talk a little bit more about variables. Now, so far in this course, we've used variables as our primary data storage method. Variables are great. They work pretty simply. But they come with some major limitations. The main one being that if I want to store information in variables, I need to know exactly how many variables I'm going to need ahead of time. So for example, let's say I want to store a whole bunch of names, in my program. Now, I'm going to need to create a variable for every single one of those names, and different implementations of this program or different times I run it, I won't be able to adjust how many variables are available. Maybe in one case I want to have 10 different names, in another case I want to have 100. With variables alone, there's not a way to adjust that to make that flexible. That's where arrays are going to come into play. We'll say an array is a group of items, all the same type, which are accessed through a single identifier. So for example, let's say I want to store some ints. What I can do is, rather than having for this list of ints here 1, 2, 3, 4, 5 different int variables, I can create a single int array and store all those variables at the int array called nums. Or I can do the same thing with doubles or Boolean values or some strings or any other type of object I want to store. So arrays essentially work as a very simple way to organize and store and then access data for our programs. As far as accessing the values in an array, we'll use integer values to access elements of the array by the index. So each time an array in Java is created, there'll be the values that it stores, and they'll be stored at a specific index. Now, we'd say that Java is a zero index language, which most computer languages are, where we'll store the first element, the first value at index 0, second value at index 1, and so on. So when I run this set of code here, if this is my array, which we'll show you how to create in a few minutes, if I print out nums at 0, that should just print out the first value in that array at the 0 index. We can do nums at 3. That would give us what's at the third index. And as far as accessing goes, there's some different ways I can use math. We can look at nums at place 2 plus 2, in other words 4. That should give me the 9 from the array. Or we could add math kind of after we've made the call to the value in the array. Nums at 2, which is 3, plus 2 should give me 5. And again, the advantage here is, rather than having 5 different variables stored, I'm able to access all these different values by just referring to nums and its index. We can also use this same convention to modify what's in our array. So for example, if I say nums1, num braces 1 gets 3, what that code's going to do is it's going to go to the index 1. It's going to remove what was there and reassign it with a 3. I can do more complicated reassignments. We can say nums at 4 gets, so we're reassigning what's at 4. Nums at 0, which would be a 1, plus 3, so as in 4. Or we can use our different addition, subtraction operators. We could say nums2 plus equals nums1. In other words, what is at nums2 right now, which is a 3, is going to get added to it what's at nums1, which would be a 3 as well, to give me a 6. Okay, so again, the advantage here is rather than having individual variables, we can access and even reassign the value of our nums array, okay, by the same convention using the same notation. Now, I'm going to say we've kind of sort of been dealing with arrays all along as we've been talking about strings throughout the course. Okay, a string is essentially an array of characters. When I make this storage here, string stir gets comp sci. What it's doing is it's storing those individual characters in an array with the same type of indices. Okay, so working with arrays is going to be very similar to a lot of the work we've done with strings so far in the course. So now that we know how to access and reassign the values of an array, let's take a look at how to actually create them. Okay, creating an array is going to be very similar to creating other types of objects. Okay, we'll talk about in a second here is array is an object in Java. Okay, we'll say the size of the array and the type of its values it stores must be determined when the array is created. Okay, so I'm going to use this kind of object creation convention where if I want an array of ints, what I'll do is I'll say int with the braces here. That tells Java we're creating an int array. And if I put a different type here, it's going to give me a different type of array. We'll give it a name. We'll say it equals new int, and then in the braces here, you tell Java how many spaces to leave in that array. Okay, how many pieces of data we're going to store. Now, when I call this array constructor, when I do the new int braces 5, the arrays are always going to start out filled with 0 values when they're instantiated. So notice my nums array here starts off with all zeros in it. We'd say that 0 is the 0 value for an int. And then if I create different arrays with different data types, such as a double array, Boolean array, or string array, okay, the values will be filled with that data type's 0 value. In the case of doubles, we'd say the 0 value is just 0.0, so 0 once again. When we're talking Booleans, the 0 value is going to be false. And then when we're talking strings or any other type of object, the 0 value will be null. Okay, strings are objects. If it's null, it's not pointing to an actual object. Okay, that kind of works as the 0 value for objects. Now, there's actually two different ways I can create and fill an array with values. Okay, we can say array values can be set using either a constructor and referencing individual indices, okay, or using just a list in the code. So when I say constructor and indices, what we could do is we could say int array nums equals new int array of size 5. And what that would do is that would create an array with 5 zeros in it to source 5 values. We could then set those values individually, okay, or a quicker way to go would just be to say int array nums gets this list of numbers here, the list I want between curly braces, and that would in one step create the array and then also fill it with the values. Okay, both these chunks of code are going to be the same result, okay, an int array called nums with the values in it. Now, as far as which method should you use, well, if you're not sure what's going to go into that array ahead of time, use the constructor and then fill things individually. Okay, but if going into the chunk of your code, you know exactly what your array wants to be filled with, all right, you can use the list instead to save some lines of code, make things happen a little quicker. Now, like we've already said, arrays are objects, so they're going to work the same way as other Java objects do. So for example, when it comes time to create an array, if I just declare it as in int array a plus without setting it equal to anything, without instantiating it, that is going to create a reference to an integer array, a plus. We'd say it is a null pointer because it's not actually assigning it to an array. Okay, a plus is a reference to an integer array that hasn't been created yet. This will be something we do all the time when we use arrays as instance variables for classes. Okay, we'll define them at the top of the class, we'll declare them, and then the actual instantiation will happen later in the constructor, just like we've done with other objects as we've written classes. Now we could also instantiate an array without declaring it, without assigning it to a value. So for example, if I just run the code new int3, there's going to be an array object that's instantiated with 3 spaces to hold, but there's no reference to it. This will be something we do commonly if we want to pass an array into a parameter list. And then we can also, in one step, declare and instantiate. Okay, this will actually create the reference and assign it to an array. Okay, so we can say that a plus is a reference that stores the memory address of an integer array which has been stored and saved here. Next up, we'll talk about one of the key properties we're going to want to be able to access for our arrays, which is the length. We'll say the length variable returns the total number of spots that are set aside for that array. So if I run the code int array r gets this list 5, 6, 7, 8, it holds 4 values, or has space to hold 4 values. So when I print off r.length, we should get that 4 for the 4 spaces in the array. Okay, now a few things about that. There's no parentheses next to the length here, like there is with strings. Okay, technically with strings, the .length is a method. Here it's a variable stored by that array as an object, not a method. Okay, now it does not return the number of valid elements, which will be something we'd look at when we're dealing with objects. Okay, and then also a reminder, the length is always 1 more than the last index. Since arrays are 0 indexed, we start counting at 0, so the length will always be 1 more than that last index. And then last thing we'll talk about is traversing arrays. Now another kind of key advantage to using arrays as opposed to just individual variables is it's very easy to traverse or loop through an array. Whereas with variables, you'd have to call code to access every single variable. Okay, with an array, we can transverse them through loops. Okay, so a traversing array just means to move through each spot in the array. So let's say I make this int array, once again called nums, okay, set to this list here. Kind of the standard code I'll use to traverse through that array is we'll say for int I get 0. And the reason, again, we use I a lot of times in Java is we're thinking in terms of indexes. We're going to run this loop while I is less than nums.length. Now remember, nums.length goes up 1 more than the final index. So that's why I'm strictly less than here as opposed to less than or equal to. Okay, and then we'll say I++ will count up by 1 every time. And within that loop, you can do whatever you want with those elements. You could accumulate them, you could search them. Okay, in this case, we're just going to print them off by saying nums at index I. And as that works, as I starts off at 0, we'll get the 0 index. As I moves up to 1, we'll print off the number with the first index, and so on until we go through our entire array. Now there's a few things we need to remember about arrays, just like we do with any object, especially when they're being passed as parameters. We'll say since arrays are objects, they're passed by reference. So let's say I have this method here, change1, which accepts as a parameter an int array called array. And what does that method do? Well, it resets whatever we pass in at index 0 to 0 and at index 1 to 1. So let's look at some code with it. If I create a int array nums with 5, 4, 3, 2, 1, and I print off elements at nums0 and nums1, we'll just get the 5 and the 4. And then when I call my method here, change1 on nums, it's going to set the value of the parameter array at 0 and 1 to 0 and 1. But now since we pass objects by reference, when I print that, nums, once again, it is going to make that change not just on this parameter, but on the actual object being passed into it. Okay, just like any object, when I create this parameter, what I'm doing is I'm pointing ray to whatever got passed in this case nums. So when I do things that are going to affect ray, it's also going to affect the parameter passed in nums. Okay, so something to keep in mind with arrays, because once again they are Java objects, so they work in the same way. Now we're going to see the same issue crop up when we go to copy arrays. Okay, so let's take a look at, we'll say, the wrong way to copy an array. Now there are certain situations where this is what you want to do, but in most cases not. So let's say I create an array num1 with the values 3, 2, 1. And then let's say num2 I want to be a copy of that original array, have the same values. Well, one thing I could do is just say int array num2 gets num1. But the issue with that is, like we've seen with other objects, if I then reset the value at index 0 of num1 to 7, when I print off the value of num1 at 0, we're going to get the 7. But we're also going to get the same thing when I print off the value of num2 for 0. Because again, what we have happening here is we have two different references pointing at the same array, this 3, 2, 1. So when I affect one, it's going to affect both of them. So the right way to copy, okay, in most cases, usually when we want to copy, we actually want two separate arrays. So this would be the way to do it. We'll create our first array, num1, we'll set it equal to 3, 2, 1. And then what I can do is I can create a second array, num2, we'll call it a new array, and we'll say int. For the size, what we'll do is we'll do the same size as num1. Okay, so in this case, num1 has 3 spaces. Okay, its length is 3. That's going to create num2 with 3 kind of 0 spaces, 3 empty spaces. And then the way to make the copy, there's really no easy way to do it. What I'm going to have to do is loop through the length of num2 or num1. And then for each index, we'll set the value at num2 equal the value at num1. Okay, a little bit more tedious than just reassigning one array to another array, but the advantage is when I make a change to num1 and print it, we get the 7 for num1 at index 0. Alright, but index 0 of num2 would still be that 3, okay, that we reassigned during that loop. Okay, now as far as which way to copy, kind of depends on your situation. If you do actually want two separate arrays that don't affect each other, you do need to loop through them like this. Okay, but if you have a situation where you want to simply take one array and use it in another part of the program, that's where we could do the, we'll say, wrong way to copy it. We'll see examples of both as we go through this chapter. Now there's one last thing we're going to need to account for when we're dealing with arrays of objects. Okay, for this example we'll talk about arrays of strings, which will work the same as arrays of any other objects. And that's going to be null pointers. So let's talk about what's happening here. Let's say we create a string array words and give it a size of 5. Okay, what Java does then is it sets aside a spot in the memory with 5 slots to hold strings, and initially it gives them all the value of null. Okay, null is the 0 value for strings and any types of objects, so any array you create that you don't explicitly assign those values to is going to start off at null. Now I can go through and assign a few of those values in that array. So let's say at index 0 we assign it from null to hello. And at index 3 we say world. Now the issue I'm going to have is if I loop through that array and need to use those strings, but don't account for the null pointers, I'm going to get null pointer or null values kind of showing up in my results. So here again, if we traverse through the array from index 0 to the array.length and just print off what's at each of those indexes, We get the hello for index 0 because we assigned that. But index 1 we never assigned, so we're not going to get a string. We're just going to get a null value. Same thing with index 2. Index 3 would give us the world because we've assigned it. But index 4 we get that null once again. Okay, maybe this is what you actually want to print, but probably not. Okay, that null, again, it's not a string. It's just saying that this index doesn't actually point to a string object. And to avoid this, what we'll have to do is if there's a chance that spots in an array could be empty, they could be null, we'll have to check and see if they are not null before we actually deal with what's in that spot. Okay, so same starting code here. We're going to create an array with 5 spaces. We're going to assign 2 of them. We're going to loop through that array once again. But this time, rather than just printing what's at each of those spots, we're first going to check and see if words at index I is not equal to null. And if it's not, we'll actually print that word. Okay, but if it is null, this code will skip over it. So when I run this, it's going to print the hello at index 0. It's going to skip what's at index 1 because that is null, skip what's at index 2 because it's null, and then print the world at index 3. And then it would skip the rest as we go through the rest of the way. And again, this will be a common kind of conditional chunk of code here. Okay, anytime we're dealing with arrays of objects, we're going to want to check and make sure they're not null first, okay, before we print them or do whatever other operation we want to do with them. All right, so that's it for 6.1 Java arrays. Okay, again, that's kind of the big picture overall view of how they work. We'll go into some of the finer details in the future lessons here. Okay, but that's enough for now. So start working on programs, start cranking out some code. Let us know if you need help. We'll help you out with it. And we'll see you next time. We'll see you later.